Dividing radicals generally requires we do something that's called rationalizing. So we generally ask students to rationalize the denominator, and basically what that means is we want to eliminate the radical from the denominator. Now I'm going to show you two examples. One is an example where the denominator is just a single radical. So when we want to eliminate the denominator here, 5 over square root of 7, we can just multiply by the radical square root of 7 over square root of 7. So that way it will eliminate the radical, because if we multiplied the bottom square root of 7 times square root of 7, we would just get 7 on the denominator, and then we multiply the top, we'll just get 5 times square root of 7. Okay, so that's what we would do there. Now, but when we have a radical involved in a binomial like we do here, 3 plus square root of 7, then we're going to multiply the denominator by the conjugate, and as long as we also multiply the numerator by the conjugate, it will keep things balanced or equal for us. But I'll show you that in an example here in a minute. Okay, so on this first example, I actually don't have to rationalize because I have square root of 2 over square root of 32 over square root of 2, and I can write that as square root of 32 over 2, which is the same as square root of 16, which is 4. So there, I didn't have a denominator when I finished that one. But on this one, now I just showed you this one. If you have 5 over square root of 7, you've got to multiply that by square root of 7 over square root of 7, so that when you multiply 5 times square root of 7, you get 5 square root of 7, but when you multiply square root of 7 times square root of 7, you just get 7, and thus you've rationalized the denominator. Now, rationalizing a cube root is a little more complicated. The problem is see over here, when I multiplied square root of 7 times square root of 7, it's actually going to be square root of 7 squared, and the square root of 7 squared is just 7. But over here I have a cube root, so what I need is, to eliminate this, when I multiply here, I need it to be the cube root of x cubed, so that I actually, when I get the cube root of x cubed, I can easily simplify that. That'll just be x. So what I'm going to have to multiply this by is, so that this will be cube root of x cubed, when I multiply, is I've got to multiply by cube root of x squared in the denominator. And then when I multiply cube root of x times cube root of x squared, I get cube root of x cubed, and then that actually eliminates the radical because the cube root of x cubed is simply x. Of course, I also have to multiply the numerator by cube root of x squared. And so if I multiply 5 times the cube root of x squared, I just get 5 times the cube root of x squared. Okay, back to a square root problem. On this one, we know that since it's in the radical, we can divide 15 into 30 and get the 2 right here. And then we know if we divide x squared into x to the 4th, we'll get x squared. And then the denominator, we can divide the y into the denominator, and that'll leave us with y cubed in the denominator. So I actually have here I have 2x squared over y cubed. Now let's see what I can simplify. I know I can take the square root of x squared out of the radical because the square root of x squared is x. And I also know if I write y cubed times y squared times y, I can take the square root of y squared out. So actually, if I write this as x squared over y squared times 2 over y, then I can take the square root of x squared over y squared as x over y out of the radical. So I have x over y there. And then in the radical, I still have square root of 2 over y. But see, I can write square root of 2 over y. I can actually write that as square root of 2 over square root of y. And then I can rationalize that by multiplying by square root of y times square root of y. So I'm going to multiply this by square root of y over square root of y. And then when I multiply that, I get x times square root of 2 times square root of y. That's just going to be x times square root of 2y. And then when I multiply the square root of y times square root of y, I get an extra y in the denominator along with the y that was there originally. And so the denominator is just going to be y times y, which is going to give me y squared. So now I have x times the square root of 2y all over y squared. And this is what I was showing you at the beginning. If I have 5 over 3 plus square root of 7, the way to eliminate the radical is to take the 3 plus square root of 7 in the denominator and then multiply it by the 3 minus square root of 7. And see what that does. Since that's difference of squares, it'll give me 3 squared minus the square root of 7 squared. And then that way I'll just get 9 minus 7 in the numerator. But I also have to multiply the numerator by 3 minus square root of 7. So if I distribute the 5, I can distribute the 5 through. 5 times 3 is 15, and 5 times minus square root of 7 is minus 5 square root of 7. So putting that all together, I get 15 minus 5 square root of 7 all over 2. So that would give me this. Now a lot of times they'll ask you to break up a radical when it's written like this into 2 terms. I wouldn't lose a lot of sleep over that, but another way to write this is just break up the numerator into 15 over 2 minus 5 square root of 7 all over 2. Okay, here's another one here. This one, the denominator has 5 plus 3 square root of 2. And so to rationalize that, I need to multiply the denominator by 5 minus 3 square root of 2. And if I multiply the denominator by that, I also must multiply the numerator by that. So if I multiply the denominator by that, since I have difference of squares, it's just going to give me 5 squared minus 3 times square root of 2 squared. We'll come back to that. And then when I multiply the 2 times the 5 minus 3 square root of 2, I can distribute the 2. 2 times 5 is 10. And then 2 times minus 3 square root of 2 is minus 6 square root of 2. So now the next step, let's just bring the 10 minus 6 square root of 2 down as the numerator. And then from here, I know 5 squared is 25. And then when I square the 3 square root of 2, I know 3 squared is 9. And I know when I square square root of 2 squared is just going to be 2. So I'm going to get 25 minus 18 in the denominator, which I did that in my head and just got 7. So again, there's the final answer, but if you're asked to write it, break it up into 2 terms, you would get 10 over 7 minus 6 square root of 2 over 7. And so that's the rationalizing concept. The only thing I can really do to make it more difficult is to show you some with denominators that might be a little more difficult to multiply out. So here I want to rationalize this one. So notice in the denominator I have 5 plus 2 square root of 3. So I'm going to multiply by the conjugate 5 minus 2 square root of 3. And then I also have to multiply the numerator by 5 minus 2 square root of 3. So I have to multiply the 7 plus square root of 5 times that. So in the numerator, I'm just going to FOIL. 7 times 5 is 35. 7 times minus 2 square root of 3 gives me minus 14 square root of 3. Then square root of 5 times 5 is the same as 5 times square root of 5. And then square root of 5 times minus 2 square root of 3 is going to be minus 2 times square root of 15. And that's because square root of 5 times square root of 3 is the same as square root of 15. Now in the denominator, I'm just going to have 5 squared minus 2 square root of 3 squared. Now I didn't show it this time, I just went ahead and did it in my head. So we know since these are conjugates, a plus b times a minus b, the result is going to be 5 squared, which is 25, minus this radical squared. So if you square the 2, you get 4. And if you square the square root of 3, you get 3. So I get 25 minus 12, which is 13. And I just bring the entire numerator down like that. Now the numerator it's kind of nasty, but you'll notice that, remember, the point of this was to eliminate the radical from the denominator, and that's what I did. Now I don't have a radical in the denominator. Now I've got one more example here, but it's pretty much the same as this one. To rationalize here, I need to multiply the square root of x plus square root of 3 that's in the denominator by square root of x minus the square root of 3, which is the conjugate of that. Okay, and then on top I also multiply. Now on top again I have to FOIL, so if I take square root of x times square root of x, I just get x. If I take square root of x times minus square root of 3, I get minus square root of 3x. And if I take square root of 5 times square root of x, I get square root of 5x. Then if I take square root of 5 times negative square root of 3, I get minus square root of 15. And then on the bottom, you just square the first term. So if I square the square root of x, I just get x. And then minus, you square the square root of 3, and you get 3. So I just get x minus 3 for that result. And that's as far as we can take that. And again, the denominator now does not have any radicals in it, so therefore I rationalize the numerator. When you get into higher math courses, there's going to be sometimes in calculus, if you ever take calculus, that you'll not only be asked to rationalize denominators, but sometimes you might actually have to rationalize a numerator. But that's pretty much it on the rationalization or division. And on the next section I'm going to talk about radical functions and then some graphs of radical functions and some of their properties.